by talking about Beer-Lambert's law, which is this formula, where
A is for
absorbance and can be found using this formula, where I of 0 is the intensity and the denominator is the wavelength. Next up is epsilon, which is the 5th letter of the Greek alphabet and represents molar absorptivity, which is how strongly the solution absorbs the light at a specific wavelength, and can be found using this formula.
C is for
concentration of the solution and can be found by setting up and solving a simple titration equation.
L is for
The path length and is simply the length of the cuvette. Beer's law states that the absorbance of a solution is proportional to its concentration, which simply stated means that as the concentration of a solution increases, the absorbance rate will increase as well, and vice versa if it decreases. After all serial dilutions are made, transfer each into the cuvette using the pipette, paying close attention not to pass the line. In this shot, our blank of ammonia does look a little low. However, we did fix this problem off camera, as you can see here. Before scanning each solution at a specific wavelength, scan your stock solution across all wavelengths to observe all the peaks in the absorbance curve and find the lambda max. When scanning across all wavelengths, the highest peak in your absorbance curve is the lambda max. The lambda max is the wavelength where the absorption rate is the highest. First, we will take our ammonia sample, clean the sides of the cuvette, place it into the spectrophotometer, and zero it. If you do not zero the spectrophotometer using a blank, then your absorbance value will be incorrect due to the ammonia molecules being red as well. Next, we will take our stock solution, clean the sides of the cuvette before placing it in a spectrophotometer and scanning it for its absorbance value. After obtaining the absorbance value, we will record it in our lab manual. We will then remove our stock solution from the spectrophotometer and repeat the process. Again, we will zero the spectrophotometer using our blank of ammonia. However, this time we will use our dilution 1 and record its absorbance value. Again, we will go through the process of zeroing the spectrophotometer using the blank of ammonia, but this time we will record our absorbance value from our dilution 2. We will repeat the same process using our dilution 3. No experiment is complete if you do not clean up after yourself.